We're going to carry on working with the form of the linear equation y equals mx plus b. Today our focus is going to be coming up with an equation in this form, but based off of tables of values. So let's start with a warm-up. This is just to remind us of some things we already know. This is taken from an old EQAO test. It's a multiple choice. Two lines are shown below, line 1, line 2. You can see that they have different steepnesses. They have the same y-intercept. We're supposed to then describe or pick the answer that best describes the difference between line 1 and line 2. So when I look at them without even looking at the answers, which is usually a good way to do multiple choice questions, is just try to answer the question without looking at your options first and then pick one that matches your ideas. So line 1 is steeper than line 2, which means line 2 is less steep than line 1. They both have the same y-intercept, which is sometimes called initial value or initial cost in this case, because it is measuring cost over number of something. So which of the answers matches that best? Let's see, line 2 has a larger initial cost. No, they have the same initial cost, so we can rule out both A and B. Neither one, they have the exact same initial cost. Line 2 has a greater rate of change, while line 2 is less steep than line 1, and less steep means a lower rate of change, so that only leaves D, because line 1 does have a greater rate of change. It's steeper than line 2. Okay, let's jump into our actual lesson for today, which has to do with coming up with equations based on tables of values. So again, we're looking at y equals mx plus b, right? So this is what we're always going back to. So today I'm going to just highlight slope in yellow. I'm going to highlight y-intercept in green, again just for a little color coding purposes. I'm going to need to know from this table of values what both m, the slope, are, and b, the y-intercept. Well, I can actually answer one of those without doing any work whatsoever. I just have to recognize it. Remember that y-intercepts occur when x equals 0. Let's just do a little visual of this. Here is a random graph, y, x. Let's throw a line across it somehow. Let's say the line looks like that. It doesn't matter what the line is. The y-intercept is definitely this point here, but wherever the line crosses the y-axis, what do we know for sure? We know the x value is going to be 0. So, going back to our table, where is the x value 0? Well, the x value is 0 here. That means that the y value that goes with it is our y-intercept. Now to get the slope, remember we need to get the rate of change. That's the same thing. I need to find the difference in the x's. In this case, the x's are going from 0 to 2 is up by 2, 2 to 4 is up by 2, 4 to 6 is up by 2. Then I find the difference in the y's, sometimes called the first differences. From 2 to 6 is up by 4. 6 to 10 is up by 4. 10 to 14 is up by 4. So we're good. And so then what we can do is we can take the change in the y's over the change in the x's. So it would be 4 over 2, which equals 2, and that is my y-intercept. Sorry, that's my slope. So y equals mx plus b. Let's write it one more time. And I have y equals 2x plus 2. This 2 came from the slope. This 2 came from the y-intercept. Okay, let's do it again. Using the table, write the following equation. Now, all they've done is taken this table and written it sideways. So don't let that throw you off. Now, in this case, if I wanted to do that, let's find the y-intercept type thing, I'm out of luck because there is no x value of 0. So there's a couple things I could do. Well, first of all, let's work with the slope, and then I'll address the y-intercept. So the x's, from 2 to 4, it's going up by 2. From 4 to 6, it's going up by 2. It's going up by 2 every time for the x's. Right? These, the y's, the first differences, are going up by 5 each time. 11 to 16 is up by 5. 26 to 31 is up by 5. M is equal to change in y over change in x, which equals 5 over 2. And I could write that as 2.5, but I don't need to. So here's my slope. And probably the easiest way to get the y-intercept that I would recommend is just continue the pattern on the table. I think I even have room I can squeeze this in here. So if I were to go left, instead of going up by 2 every time, I would go down by 2. So from this blank I've written here to 2, it has to go up by 2. So what does this number have to be here? This one has to be 0. So this is the one that I'm going to want, where x equals 0. And if I go down by 5 from 1, that'll take me down to -4. So I get my y-intercept that way. So y-intercept is -4. Another way I could have done it, though, is I could have, well, actually, let me just finish this equation off, and then I'll show you the other way I could have done it. So y equals 5 over 2x minus 4, right? That's the answer. But the other way I could have done it is I could have taken that slope once I knew it, and then I could have found b by taking any point from the table and substituting it in. So let's say I randomly just pick a point. Say I randomly pick the point 1021. If I plug that in there, that means 21 would go in for x, 10 would go in for, 21 would go in for y, 10 would go in for x. And what I get when I multiply 10 times 5 is 50, divided by 2 is 25. Isolate b, so I'll subtract 25 from each side. And lo and behold, I got my b this way as well. So that's an algebraic way of getting the b value, but obviously it's more work, and it's not necessary if you understand the pattern that's going on for the table of values. All right, using the table, write the equation of the line in the form y equals mx plus b. Can I grab the y-intercept from this table? Yes, I can. There it is, right there. And as for the slope, all right, from -3 to -2, we're going up by 1. We're going up by 1 every time. As for the y, the difference in y's, the first difference is we're going from 10 to 7. We're going down by 3. That negative sign is very important. Don't leave out the negative sign. 7 to 4, down by 3. 4 to 1, down by 3. We're going down by 3 each time. So our slope is -3 over 1, or just -3 is good enough. So I'm going pretty quick on these last couple because it really is fairly quick once you get the hang of it. The last couple here that I haven't done yet are multiple choice. So again, though, I would just answer the question first. Let's cover up the multiple choice parts here, at least on my screen, so I can't see them, and just answer the question and then pick out the correct answer once I've got my answer. So I want to find an equation for example 4 here. Well, here's my y-intercept, 5, and my slope, 1, 1, 1, 1, obviously going up by 1 each time, and this is obviously going up by 10 each time, means that slope is going to be 10 over 1, or 10. So there's my slope. Write my equation, y equals 10x plus 5. And then I can see, does that match any of the answers? Well, look at that, it matches C part. That's how I would say to do this. And I guess the only thing I should talk about is I was just doing in terms of x and y because that's what I was used to. I wasn't even paying attention to the fact that there's distance and time. But d is like my y value, t is like my x value, so hopefully that's an easy adjustment you need to make there. Last example, again, I am going to hide the answers and just try to solve this. I can't see my y-intercept right away, so I'm stuck with doing the slope first. From negative 15 to negative 9 is up by 6. We're starting at the lower number, negative 15, and going up by 6. And then from negative 9 to negative 3 is up by 12. Something funny is going on here. And then from 3 to 12 is up by 9. So our x's aren't going up by the same amount each time, so that adds a little wrinkle. Let's see what the y's are doing. Negative 33 to negative 25 is up by 12. No, it's not up by 12. I can't count. It's up by 8, isn't it? And from negative 25 to negative 9 is up by 16. And from negative 9 to positive 3 is up by 12. So, how am I going to get a slope from this? Well, remember our slope formula? I can get our slope from 2 points. I've actually got, these are actually 4 points here. Here's a point, here's a point, here's a point, here's a point. Those are ordered pairs, right? I could think of them as x1, x2, x1, y1, x2, y2, x3, y3. I don't need to use all of those, but I could use all of them if I needed to. But actually, getting, say, this, going from negative 15 to negative 9 is like doing the bottom of my slope formula. So let me write out the slope formula since we haven't talked about it in this lesson. So this x2 minus x1 is really just subtracting the first number from the second number, which is exactly how I got that 6. And to get my y value, my numerator, I'm subtracting the first number from the second number in the y's, which is pretty much exactly how I got the 8. So I could just do 8 over 6. And that reduces to 4 over 3. But what happened if say I took different points? What if instead of taking those first two, I took, trying to erase, what if I instead took those middle two numbers? Well, it doesn't matter if it's linear, because I could have done 16 over 12, but that still reduces to 4 over 3. Or I could have done 12 over 9. That still reduces to 4 over 3. It doesn't matter which pair of points I use, it's always going to reduce to the same thing if it's linear. So, whichever points I choose, I get a slope in reduced form, which it needs to be, of 4 over 3. Now I have to get the y-intercept. Now, I guess, again, I could sort of play around with the table, but maybe it's easiest just to do it algebraically for this one. I could go y equals 4/3 x plus b, and then I could take any point. I'm going to stick with a point that's got a couple positive numbers in there just to make it easier. So if I put 3 in for y, and I put 12 in for x, and then solve this for b, remember multiplying 4/3 times 12, multiply only the numerator by 12, I get 48, then divide that by 3 equals 16. Then I'll subtract 16 from each side, and I get negative 13. So there's my y-intercept. Here's my full equation. Y equals 4/3 x minus 13. And look, that appears to be one of my possibilities, doesn't it? It's B part.